Hey everybody, it's Joe, graybenchelec. Welcome back to the bench. So we're going to continue the build on the Garnet Stinger Fuzz. Last week we looked at the different schematics that are available, essentially two, for the Garnet Stinger, one using the earlier 6A and 8, earlier design with a 6A and 8 tube. The later design was a single 6JWE just using the pentode for the fuzz. We're going to build the earlier version, which has this DC coupled triode after the pentode. This is the schematic I've drawn up for what we're going to build. It's essentially taken right out of the Garnet, I can't remember which model it was, the Rebel L90 schematic. I just quickly wanted to go over a couple things we're doing for the power supply. So this is going to be the transformer we looked at last week. It is the 261C6 from Hammond. We have our high voltage winding here. It's going to be rectified with a couple UF5408 rectification diodes. Down here is our heater winding. The power setup here is going to be, I more or less just looked at the, I think the matchless hot box it's called, for how they did their high tension or B plus setup. And it was just, it's pretty standard, just a couple, just a string of resistors and capacitors, pretty standard to any tube amp. At the end here is a half supply setup, providing a DC voltage for the heater supply. So the heater winding here is going to be lifted above ground via this connection here between these two 100Ks. Depending on the actual voltage, I might end up making this lower 100K a little bit lower, maybe a 68K, something like that, because this doesn't have to be whatever half the supply is. It doesn't have to be that high, really. It could just be around 100 volts would be fine. And then a filter capacitor off that junction as well. Down here, so these are the two bouncing resistors, 100 ohm resistors. These are going to be connected to that DC elevation point. And then there's also 1 ohm series resistors to the heater winding, because when I used this transformer in the past, I remember that the heater voltage ended up being a little high. The primary here is designed for 115 volts. Modern wall voltage is going to be more like 120, like low 120s, 120 to 125, something like that. So these 1 ohm resistors are going to be just enough to drop the voltage down into a more appropriate level, somewhere between like 6.2 and 6.5 volts for standard 6 volt tubes like the 6A and 8. Another change from the end of the previous video is I had initially talked about doing the tube inside the enclosure, but what I recall from the last time I built this is it gets really difficult to wire up stuff inside here, especially because you're fighting inside an enclosure. So I decided, at least for this version, who knows, if this turns out to something really cool, I might even do like a PCB. But for now, I decided I'm just gonna exterior mount this tube socket. It's gonna make wiring this stuff a lot easier. I'm also going to assemble what I can outside of the enclosure here. Anything that's symmetrical can be wired outside of the enclosure so you're not inside fighting with components. So we're going to do at least a little bit of that. Components wise, I have some Panasonic filter caps. These are the 33 microfarad filter caps here. Resistors and capacitors, pretty standard stuff. Got some terminal strips for different connections, going to be wired point to point, at least this version. Got our power switch. This is a single pole, single throw power switch, technically for a captive power cable. I'm going to use here just a standard power cable with a little strain relief connector. Technically, you're supposed to switch both the hot and the neutral side of the cable. This is the switch that I had handy, so it should be fine for this version. This version, I have no plans to sell it, so this will just be for me, and I know what I'm doing. I'm careful, so. Fuse area looked at, input and output jacks, nothing crazy there, standard switchgrass number 11s, and associated hardware to connect everything, and I think that's it. So let's get right to building, and hopefully by the end of this, we'll have a complete product, and we'll be able to do a listening test. All right, so here is the final build. This is the Garnet Stinger. Just one small change I made to the schematic that I showed earlier in the video. I added in this resistor that's going across the volume pot. It's shown in the schematic and I forgot to draw it here and I just put it in. Went with the 150K because I think I've seen that on other schematics. The schematic we looked at, the L90, had 100K, so I threw that in there and we'll see what happens. It should just affect sort of the sweep of the pot. Shouldn't have a meaningful difference to the actual sound of the pedal at all. So I got the pedal all hooked up here to power. I thought we would just have a quick listen. It does have a tube currently plugged in. That is I don't know if I showed it earlier in the video or previous video, but that is a Sylvania 6A and 8. I got another 6A and 8 here we can try as well. I just want to look at the voltages. I also realized in the first video I mathed my math wrong. I rectified 250 volts center tapped secondary on the transformer wouldn't be 250 volts times 1.414. It would be times 0.707. So it should be around 200 volts at 120 or 176 at 115 volts. So that's more what we're expecting to see here. All right, so let's turn it on. I've got it hooked into my variac here and we can clip on. So this is the first power node. Clip on the ground. All right, so we're at 60 volts on the first power node. It's gonna come up here. All right, so here is 115. So this is what the primary of this power transformer it calls for. All the numbers are based on 115 input, and we're right around 200 for the secondary, so a little bit better than we expected, which is, it could just be variance in the actual winding amount. So that's the first node. We can go to the node that actually feeds the tube itself, 192. Here is the elevated DC supply for the heaters, 95. And we can look at the actual plate. This is the plate of the pentode and the grid of the triode because they're DC coupled together. It's got a 1.5 meg resistor there, so that's dropping a lot of voltage across that. And let's see. This is pin 1, so this is the plate of the triode here, 39.7 or so. The cathode of the triode, this is 220K resistor, it's 21 volts. And what else? This is the screen of the pentode, 18 volts. We can also check the heater voltage. So at the heater, let's go back to AC. So we're at 150 volts at the wall, and we have 3.123, which is good because it should be 3.15 for 6.3 volts total. Looking at one side here. If we push it up to 120 volts on the wall, or actually maybe a little more, we'll do 122. There's 122. And look at the heater. We're at 3.3. Yeah, 3.3. If we look at before those 1 ohm resistors, it's actually 3.78 actually coming out of the transformer. So those resistors are dropping about 0.4 volts, bringing down the heater voltage to a safer level. Theoretically, you run the tube at a higher heater voltage, it could wear out the heater faster. Although, old tube amps are going to be running tubes at this high voltage anyway, so how much it actually matters is hard to say. All right, power off. So those are the voltages that are currently running in the pedal. Let's go ahead and hook it up to, I'm going to hook it up to my little practice amp on the table because I have a feeling the sounds that are going to come out of this thing are not going to be particularly pleasant. So I'll spare my trouble hooking up all the mic and everything and also your ears, and we'll just listen to the little speaker on the table here. All right, got the Garnet Stinger fuzz pedal clone thing hooked up to the test amp on my bench here just for a little listening test. This is the Sylvania 6A and 8. I got about 117 volts on the variac, just running those heaters just a little bit easier. And on the left here we have the volume, and on the right is that tone control. The amp is turned on, so we can just kick on the pedal here. Current draw jumped up to about 100 milliamps. All right, kick on the pedal. All right, so it makes sound, which is cool. There was a question mark whether that was going to happen. Got some oscillations. Tone control seems to generally work. lot of volume on tap, holy moly. Yeah, pretty unruly, but it's making a fuzz sound, so you can definitely hear there's a lot of like high-pitched extra crap in there, and it's got a ton of gain and a ton of amplitude happening. Let's go ahead and turn the pedal off, and we'll swap in a different tube just to see what happens. All right, so this is an RCA 6A and 8A. There you go. Throw this in here. And why don't we just throw on the tube shield for good measure. All right. Turn on the pedal. Current didn't rise as high this time, just probably slight differences in the heater. Heater is glowing, so that's good. All right, kick it on. Yeah. Definitely some oscillations there. You can also hear that there's definitely a bad bias sound, like that really sputtery fuzz sound, which could be contributed to the grid leak bias that's on the pentode. Plenty of volume again. Cool. This one seems a little more, there's a little more to it, a little more oomph than the Sylvania tube. Cool. So it's definitely fuzzing, definitely has a sound. I wouldn't call that a particularly great sound. Definitely sounds like a missed bias sort of thing, and there's a lot of oscillation going in there. We're cramming the whole thing into this pedal enclosure. I also have big power lines outside my house to throw all kinds of like EMI around my room here. So I was using a humbucker though, so that should have helped a bit. Tube shield didn't seem to make much of a difference. But yeah, it's theoretically a working concept. It definitely, I think it could be improved with, could have used shielded wires for the input and output. I use straight wires, just, you know, not shielded wires there. That might make a bit of a difference. And also using a circuit board could also cut down on some of these lead lengths. That might make a difference as well. Anytime you got a high gain pedal like this, the shorter copper traces you can have or wires, the better. But yeah, it technically works. Definitely cool amps from Garnet. I really enjoyed this project. If you enjoyed this video or the series, I'd appreciate you hitting the like button and subscribing. If you have any questions, feel free to leave them in the comments. I am Joe from Graybench Electronics. Thank you for watching.